Welcome to the Deep Dive, where we try to slice through the noise, the complexity, and really get to the insights that matter most to you.
Yeah.
Today, we're diving into something that, well, it pretty much powers almost every app and website you use, even if you don't see it. JWT Authentication. Ever wonder how your banking app, keeps things secure after you log in just once? Or how Netflix just knows it's you on your phone, your tablet, your TV, without bugging you for a password constantly? Yeah, well, this deep dive is definitely for you then.
That's right. We're going to unpack JSON Web Tokens, or JWTs. Think of them as the digital passports of the internet, really. We'll explore what they are, sure, but also how they work, and maybe more importantly, the big problems they actually solved. Problems that genuinely reshaped the web. And, why understanding them is just so critical right now, here in 2025.
Yeah, we've pulled together some really good material for this one, including a great beginner's guide that breaks it down nicely.
Okay.
Our mission today, give you that clear picture, those aha moments, so you walk away feeling like, okay, I get it now, maybe even a little inspired. All right, let's get into it. So, okay, basics first. Someone hears JWT, maybe sees it in some tech docs. What is it, actually? Why is it such a big deal?
Right. So think of a JWT JSON Web Token, like a secure digital ID card. Imagine you're at, say, a VIP event. You show your main ID once at the front door, right? They check it, give you a special wristband. Then for the rest of the night, you just flash that wristband to get into different areas, the VIP lounge, whatever. No need to pull out your driver's license every time.
Okay, I like that analogy. Makes sense.
A JWT is kind of like that wristband in the digital world. It's a standard, a widely used one for securely saying, yep, this user is who they claim to be. Works for websites, mobile apps, those APIs running behind the scenes. It just ensures only authorized people get access to protected stuff like your email or your bank details.
So it's not just proof you got in. It's like the proof itself carries the verification.
Yeah.
Pretty clever. And I hear these tokens have like 3 specific parts, almost like a code within a code.
Exactly. It looks like just a long string of characters, but
Yeah.
it's actually 3 distinct pieces separated by dots. It's quite elegant. First up, you've got the header. This basically says, okay, this is a JWT, and here's the encryption method we used, like the cover page.
Got it. Type and method.
Then comes the payload. This is the real meat of it. It holds the actual claims, the information, like your username, maybe your role admin, customer, whatever, and often critical details like when the token expires.
So the who, what, and when.
Precisely. All the stuff the application needs to know about you and what you're allowed to do.
Hmm.
And then the third part, the signature. This is the security linchpin. It's a cryptographic stamp. Basically a complex calculation using the header, the payload, and a secret key that only the server knows.
A secret key. Okay.
Yeah. And this signature is what proves 2 things. 1, the token hasn't been messed with, and 2, it genuinely came from the server that issued it. If anything in the header or payload changes, even 1 character, the signature check fails. Boom, invalid token.
Wow. Okay, so that signature is like this super strict bouncer, making sure nobody slipped anything past. All right, walk us through it then. Let's say I log into my streaming service. How does this JWT thing actually happen?
Sure. It's actually a pretty smooth process from the user's end. First is login. You type your username, your password, the usual. The server checks those credentials. If they're good, instead of just opening the door, it creates that unique JWT just for you for that session.
Okay, so it makes the wristband.
Exactly. That leads to token issuance. The server sends this digitally signed JWT back to your device, your browser, your phone app. Now, from this point on, whenever you do something that needs you to be logged in, maybe clicking on your profile, accessing account settings, watching something specific, that's the accessing resources part. Your device automatically includes that JWT with its request to the server, like showing the wristband again.
Okay. So it's not like I'm consciously sending it. My browser or app just handles that automatically.
Most of the time, yes. It's usually stored securely, maybe in browser storage or app memory, and sent in the request headers.
Gotcha. And the server checks it every single time.
Every single time for protected resources. That's the verification step. The server gets the request, sees the JWT, and quickly does 2 crucial checks. First, it verifies that signature using its secret key. Is this legit? Has it been tampered with? Second, it looks at the payload. Is this token expired? Does this user have permission for this specific action?
Right.
If everything lines up, signature's good, token's not expired, permissions match, access granted. You see your profile, the movie plays. If anything fails, access denied, maybe you get logged out or see an error.
And you mentioned tools like Spring Security. They handle a lot of this heavy lifting.
Oh, absolutely. Modern frameworks, whether it's Spring for Java or libraries in Node.js, Python, whatever, they often abstract a lot of this. Developers configure it, but the framework handles the tricky parts of creating the signature, verifying it on incoming requests. It makes life much easier.
Okay, that makes sense. Which leads nicely into the why. JWT didn't just, like, pop up for fun. It obviously solved some big problems.
All right.
And this is where it gets really interesting, right? Because it wasn't just a small improvement, it feels like it changed how things were fundamentally done.
You're spot on. Before JWT became widespread, authenticating users, especially at scale, was, well, it could be a real nightmare. Think about the old way, server-side session management. Every time you logged in, the server had to create a session record for you. It stored your login status, maybe some preferences, directly on its own memory or in a database connected to it.
Okay. It sounds straightforward enough for one server, maybe.
For a few users, yeah, it was fine. But think about millions of people logging into Facebook or Amazon at the same time. Each active user needed a chunk of server memory or a database lookup. It became incredibly resource intensive. Servers got bogged down, apps slowed down. It directly limited how many concurrent users an application could realistically handle. It was like a bottleneck.
Right. The server itself becomes the weak link.
Exactly. And that led to cross-system issues. If your session was stored on server A, what happened if your next request got routed to server B?
Server B wouldn't know who you were.
Precisely. Or what if you logged into the website but then opened the mobile app? Sharing that session state across different systems, different servers, even different data centers. It was complex and brittle. This naturally created serious scalability limits. You couldn't just easily add more servers to handle more load because you had the sticky session data problem. Growing a global application was way harder.
So it wasn't just performance, it was architectural limitations too.
Definitely. And on top of that, you had potential security risks. If an attacker could somehow steal a user's session ID, they could potentially hijack their session. Methods varied, but some were less robust than today's standards. Plus, building authentication for these newfangled distributed systems, like microservices, it was a custom, complex integration nightmare every single time. Error-prone, time-consuming.
Wow. Okay, so it sounds like developers were constantly battling session management instead of building features. How did JWT just fix all that?
It's that stateless nature we talked about. That's the magic bullet, really.
Yeah.
JWT fundamentally eliminates server-side storage for session state. The server doesn't need to remember you between requests. All the necessary info, who you are, what you can do, when your access expires, is right there in the token.
So token carries its own context.
Exactly. The server just needs to verify the token's signature and check its contents. This massively reduces the load on the server. One server, 1,000 servers, it doesn't matter as much because they don't need shared session memory.
Okay, that sounds huge for scaling.
It is. It directly enables cross-system authentication. That same JWT you got from the website login. Your mobile app can use it to talk to the same backend API. Microservices can easily validate it. It just works across boundaries.
Much smoother.
Which, naturally, improves scalability dramatically. Apps like Netflix or Spotify can handle millions of concurrent users, partly because stateless authentication lets them distribute the load efficiently across tons of servers worldwide. And security. That cryptographic signature enhances security. Because the token is signed with a secret key, it's computationally infeasible for an attacker to forge a valid token or modify an existing one without detection. Any change invalidates it.
So it's self-protecting, in a way.
In a way, yes. And finally, because it's an open standard, RFC 7512 for those interested, it simplifies development. There are well-tested libraries in virtually every programming language. Developers aren't reinventing authentication logic from scratch every time. They can plug in a JWT library and focus on their application's core features.
Okay, it's clear how it addressed those past headaches. But let's fast forward to now, 2025. Why is JWT not just, a solution, but seemingly this solution? Why is it so critical today?
It really comes down to how perfectly JWT fits with how modern software is built and run. First off, the rise of microservices and cloud computing. Almost everything significant being built today uses microservices, small, independent components talking to each other. Think of an e-commerce site. Separate services for user accounts, product catalogs, shopping carts, payments. JWT lets each service securely verify the user making the request independently. No need for constant calls back to a central auth monolith.
Right, each service can trust the token.
Exactly. And cloud platforms, AWS, Azure, Google Cloud, they thrive on these distributed architectures. JWT is often the standard way to secure communications between cloud functions, APIs, and different managed services. Then, obviously, growing cybersecurity threats. It's relentless. Data breaches, identity theft. It's constant news. JWT's reliance on strong cryptography provides a solid layer of defense. That signature makes it incredibly hard to impersonate users or escalate privileges, which is crucial for protecting sensitive data, whether it's financial info in your banking app or personal details on social media.
So it's a more robust defense against modern attack vectors. Makes sense.
And think about user expectations. We demand seamless user experiences, right? We want to log in once and have access across our laptop, phone, maybe our smart TV.
Yeah, logging in repeatedly is just annoying.
Totally. JWT enables that single sign-on feel. One token can grant you access across multiple related platforms or apps without constantly re-entering your password. That improves usability and keeps people engaged. Then there's sheer scalability for global apps. Platforms like X, Amazon, Google services, they operate at an insane scale. Millions, even billions of users. JWT's stateless nature is fundamental to making that feasible. Servers can handle far more requests because they aren't managing resource-intensive session state for every user. It's efficient, cost-effective.
So it helps keep those massive services running smoothly.
Absolutely. And don't forget regulatory compliance. Especially in sectors like finance or healthcare, you have strict rules like GDPR, IPI, PCI DSS about data protection and access control. JWT helps organizations meet these requirements by providing a secure, verifiable way to authenticate users and ensure only authorized individuals access sensitive data like patient records or credit card details.
Right. It provides an auditable trail of access based on verified tokens.
Precisely. And finally, back to the developer efficiency. In a world where businesses need to move fast, using a standard like JWT with great library support means teams can implement robust security quickly. Frameworks like Spring Security or platforms like Auth streamline it. You're not spending months building custom auth. You're leveraging a proven standard. That speed is a competitive advantage.
And we see this everywhere, right? It's not theoretical. Like when I use e-commerce sites, say Amazon.
Yep. Mechanisms very similar to JWTs or JWTs themselves are working behind the scenes, securing your login, your order processing, your payment information.
Or scrolling through social media like X.
Same idea. Tokens verify you are who you say you are with every request to load your feed, post an update, or send a message.
And APIs, like if a developer uses Google Maps in their app.
Definitely. Google, like many API providers, often uses JWTs, or a related standard like OAuth 2.0, which heavily involves tokens, to secure access to their services. The token proves the calling application is authorized.
Even for a small startup, maybe building a fitness tracker app.
Absolutely. A small team can leverage JWT libraries to quickly add secure login for users, protecting access to their workout data and plans, whether they access it via the web or a mobile app. It scales down just as well as it scales up.
Okay, so it's pretty ubiquitous. For listeners who are thinking, okay, I need to understand this better, or maybe want to implement it themselves, where should they start? It sounds complex.
It can seem daunting, but it's definitely learnable. My advice. Learn the basics first. Don't dive straight into code. Focus on the concepts. Header, payload, signature, statelessness, the overall flow. There are fantastic tutorials on sites like Free Code Camp, or just search on YouTube, get the why and what before the how.
Conceptual understanding first, good tip.
Then, explore frameworks. If you're using, say, Java, look into Spring Boot with Spring Security. If you're in the JavaScript world, Node.js has libraries like JSON Web Token. Or check out identity platforms like Auth or Okta. They handle a lot of the complexity for you, which can be great for learning too. Spring's own website, spring.io, has excellent guides for getting started with security.
So leverage the tools that exist.
Absolutely. And the best way to really cement the knowledge: build simple projects. Don't try to build Facebook on day one. Make a basic to-do list app where users have to log in. Implement JWT Authentication to protect access to their personal lists. That hands-on experience is invaluable.
Start small, build confidence.
Exactly. Use tools that help. Spring Initializer. Start.spring.io is amazing for bootstrapping a Spring Boot project with the right dependencies. Online JWT decoders can help you visualize the token parts. And finally, join communities. Don't be afraid to ask questions. Stack Overflow has countless JWT questions already answered. Reddit forums like programming or specific language subreddits are great places to learn from others and get help when you're stuck.
Good advice. Don't learn in a vacuum.
Definitely not. The community is a huge resource. So, summing it all up, JWT authentication is really this cornerstone technology now. It's a secure, it's flexible, a very scalable way to verify users are who they say they are. It tackled those big, messy problems of the past, like server-side session complexity and scaling bottlenecks, making it pretty much essential for modern applications.
Yeah, and looking at 2025, you really see its importance just amplified, right? With microservices everywhere, cloud being the default, those constant cybersecurity threats, and just us as users expecting everything to work seamlessly across all our gadgets, JWT sits right in the middle of all that. For you, the listener, getting your head around JWT, it's not just academic. It's a really practical skill for building secure, professional-grade applications. It prepares you for how things are actually built today. Secure Auth isn't optional anymore, it's table stakes. It's kind of amazing, really, how this relatively compact little token powers so much of our digital interaction.
It is fascinating. And what's really interesting to think about now is how that core idea, the statelessness, has enabled so much. But it also raises a question for the future, doesn't it? As apps get even more distributed, maybe more fragmented, and you have AI services needing richer user context, but maybe without traditional sessions, how will these principles behind JWT evolve? How do we maintain that security and privacy across an ecosystem that's constantly changing and getting smarter?
Hmm, that is definitely something to chew on. How does identity verification adapt in an increasingly intelligent and decentralized world?
Hmm.
Well, thank you for diving deep with us today and unpacking JWT. Really insightful.